Just math, y'all. Welcome back. We're going to look at synthetic division, and then we're going to get into zeros of polynomials. Here we go. All right. So first of all, let's think about division. What do we learn from division? We learn what factors are. And we know 4 is a factor of 32 because when we divide into 32, we have a remainder of 0. And we know that factor 5 is not a factor of 73 because we have a remainder. So that's an important concept that we're going to look at. Is 4 a factor of 32? No. How do you know? Sorry. Yes. How do you know? Because the remainder is 0. Is 5 a factor of 73? No, because the remainder is not 0. It's actually 3. So now, the remainder from a division problem will tell us whether a number goes into it or not. Right? It tells us a little bit more than that when it comes to polynomials, and we'll get more to that in a minute. So now, for this third question, it says if 7 is a factor of 1778, what is the remainder going to be when we divide? Okay, so we know that 7 is a factor. So we automatically know that the remainder is going to be 0. Just from the fact that we use this word. So when we have a factor, then the remainder is 0. That's a crucial point for you to understand. Okay, and also what you need to know is that when we know one factor, we can divide to find the other one. So if 7 is a factor of 1778, then we can actually do the division and we get the other factor. This is the other factor. And if we want to know more factors, we can divide it. We can take this one, the 254, and find other factors. Well, I know that 2 is a factor. It's even. And so once I know one factor, I can divide to find other factors. And then I can take the answer from that division and find other factors. So this is an idea that we will be exploring. Let's get moving. Okay, so when it comes to polynomials, we use a method of division called synthetic division. Now you can do long division. Long division is a method that is taught, and you may find it in your, if you're researching other sources or watching Professor Leonard, you'll find long division. But I'm not going to go through long division. I'm going to try to avoid long division. I think it's just too difficult for the most part. We're going to stick with synthetic division. All right. And so we need to learn how to do synthetic division for any problem. And we will always be able to look at our remainder and find out information about that. But let's just do a division problem. So the first thing we're going to do is we got to know what degree it is. We talked about degree of polynomials. Hopefully we talked about it. But if we didn't, send me a email or text or something, let me know. But this is degree 5. So when I do synthetic division, I'm going to have a 1, a 0, a 0, a 7. Wait a minute. Sorry. A 1, a 0, a 7, another 0, 5, 4, 3, 2, another 0, and 8. Okay, so where did those zeros come in? Those are placeholders because I don't have an x to the 4th, I don't have an x to the 2nd, I don't have an x. So I have 3 zeros based on the powers of x that I do not have. All right, so now I'm dividing by x minus 1. Well, x minus 1, if I were to divide by the 0, I'd be dividing by positive 1. So I'm going to divide by positive 1. You always divide by the 0. The 0 of the factor. Okay, now synthetic division is not hard. It's It's pretty straightforward. The first thing we do is we bring down that first number. So bring down the lead number. That's supposed to be a bring. Bring down your lead number. That's your lead coefficient. Okay. And then we're going to multiply. All right, we'll change colors for that. I'm going to do 1 times 1, multiply here, and I'm going to put my answer in the next column. Okay, so I multiply, and then I'm going to add. I'm going to add 0 plus 1 and get 1. And then I'm going to do it again. So multiply and then add. Repeat. All the way down. So 1 times 1 is 1. And then I'm going to add 7 plus 1 is 8. I'm going to do 1 times 8 is 8. I'm going to add and I'm going to get 8 again. 1 times 8 is 8. I'm going to add, get 8 again. 1 times 8 is 8. I'm going to add this time and get 0. Okay, now each time I was multiplying 1 times each one of the numbers that was on the bottom, and I put the answer in the next section. Okay, and so this is officially my answer. This number right here is my remainder. So let's get my answer out. Okay, so now we removed the x's to the fifth. So if I divide by x to the fifth and I divide by an x to the first, then that first one's going to be an x to the fourth. So my answer is 1x to the fourth plus 1x to the third plus 8x to the second plus 8x plus 8. And I have a remainder of 0. And that's my answer to this synthetic division problem. Okay, this one was hard, but the synthetic division process is pretty easy. So let's move on to another example. Okay, so now this one, we're going to use synthetic division, but remember what I said, that last number is our remainder. Okay, and so this is the remainder theorem. It says that the remainder you get from dividing is equal to the same number you get from plugging in. Find f of -2. Okay, so I'm going to do synthetic division with -2 real quick. So we're going to multiply, and that's going to give me a -10. And then I'm going to add the -13, multiply, I'm going to get 26. Add, I'm going to get 22. Multiply, I'm going to get -44. Add, and I'm going to get -40. This is my remainder this time. All right, this is a third degree, so my answer is a second degree. So my answer to this division problem is 5x to the second minus 13x plus 22. And I have a remainder of -40, and this is how we write remainders. Okay, but what this theorem is telling us is the remainder is the same as plugging in. So I'm sorry, if I plug in -2, I should get -40. So let's see if I do. This would give me a -8 times 5, which is a -40. That gives me a 4, so that's -12. This gives me +8. Strange how that's being weird. +4. And so I get -40. Okay, so the answer here is -40, not this polynomial. I think I don't want to confuse you, but I want you to know that this is the answer to the division problem, but this is the answer to the question. The question said, find f of -2. Well, f of -2 is -40, and I can get it either way. That's what the remainder theorem says.